the many topics you will cover in CBE205 is how cells grow along with the characteristics of their growth. Today, you will specifically learn about algae culturing and the methods of cultivating algae cells.
At this point, you're probably wondering what algae culturing actually is, what it involves, and how it's done. Well, to start, algae culturing involves the farming and production of algae and is especially targeted at phytoplankton, which is microscopic algae. You may be wondering why it is beneficial to grow algae, so here are a few applications that algae has. First, algae is often found in food because it is an excellent thickening agent. Next, algae is used to produce biofuels as an alternative to fossil fuel consumption. Since algae can consume carbon dioxide, it is good for pollution control. Algae can also be used in pharmaceuticals, since it has antibacterial, antifungal, and anti-inflammatory properties. Currently, it is being used to treat diseases caused by protozoans, which are microscopic organisms. Algae can also be used to remove contaminants from environmental surfaces in a solar energy-driven technique called phytoremediation. Lastly, algae is used for wastewater purification. Due to its synthetic capabilities, algae can convert solar energy into useful biomasses while eliminating harmful elements like nitrogen and phosphorus. There are several engineering considerations you must take into account when culturing algae. The first factor to consider is light levels. Algae culturing can be done with natural sunlight or artificial light, depending on the environmental conditions and the type of system you are using. If using artificial light, it is important to understand that only a small band of light is photosynthetic. A specific wavelength of light must be used to increase photosynthetic activity based on the type of algae you are culturing. The next factor you must consider is carbon dioxide levels. You must have enough carbon dioxide in your system in order to avoid photorespiration. Lastly, you must also consider mixing. Cells and nutrients must be well distributed in your system, and gas and heat must be able to transfer efficiently. Also, algae cells need to be exposed to similar amounts of light to increase photosynthetic efficiency. Now you'll learn how algae is propagated in both open and closed systems.
The two methods of algae culturing are open pond and photobioreactors. One method of algae culturing is an open pond technique. They typically consist of shallow pools that are consistently stirred by paddle wheels. Open ponds receive their photosynthetic energy from natural solar radiation. However, the conditions of open pond systems can be hard to maintain due to environmental conditions.
When considering how to design a photobioreactor, you should think about the following. To be most efficient, photobioreactors should have a large surface area to volume ratio. The tubing should allow for maximum photosynthetic activity, and there should be a gas exchange unit to provide CO2 to the system.
Photobioreactors can be split up into the following categories: tubular, flat plate, and fermenters.
There are two types of tubular photobioreactors: vertical and horizontal. Vertical photobioreactors have CO2 bubbles from the bottom of the reactor that float up to the top, and it allows for good mixing and O2 uptake. However, there is a disadvantage. The scale-up is very difficult. The other type of tubular photobioreactors is the horizontal type, and these have a gas exchange unit, and it is angled toward the sun. Some disadvantages of this are that it requires a large quantity of land, since it is horizontal.
The last type of tubular photobioreactor is the helical tubular reactor. The system has a flexible and coiled tubing framework, which reduces the amount of land area needed per system. One of the few drawbacks to this algae culturing system is that pumping to the framework can cause a large amount of shear stress. Although helical reactors obtain light energy from solar radiation, light sources can be installed inside the coils to maximize efficiency. Flat plate photobioreactors consist of narrow panels with large surface areas. They have high photosynthetic efficiencies, work well for mass algae cultures, have low oxygen buildup compared to tubular photobioreactors. They use solar light energy. However, some of the difficulties include scale-up and inconsistent temperature.
Fermenters are the least explored area of photobioreactors. They can be used for algae that has to be heterotrophically grown. They also can use artificial light. They tend to have a low surface to volume ratio.